All right, let's look at 11.4, the practice problem number 4. Again, I always like to read it first before I go any further. And it says 2 fire lookout stations are 15 miles apart, with Station B directly west of Station A. Both stations spot a fire. The bearing of the fire from Station A is south 28 degrees west, and the bearing of the fire from Station B is south 49 degrees east. How far to the nearest tenth of the mile is the fire from each lookout station? Well, again, I like to draw a picture. So much easier to understand if we look at it in a picture point. So there are 2 stations that are 15 miles apart. So let's call them Station A and B as it's stated. Now, Station B is directly west of A. So A is going to be on the right. Make that A and make this one B. And they connect, and we know that they're 15 miles. Then it says both stations spot a fire. The bearing of the fire from Station A is south 28 degrees west. So let's think about the north, south, east, west planes. And if I do that, remember that when we're talking bearings, that first indication tells us from which part we start with. Well, this would make a 90-degree angle. And it said it was south 28 degrees west. So from the south, I start on the southward way. I would go 28 degrees west, and then I would have a line. So we'll just call that here. Maybe something like that. And then the bearing from the fire station B is south 49 degrees east. Well, that makes sense. If we're starting from the south, again, making a 90-degree angle, I would want to go 49 degrees east. Well, it would have to go east if I was going to spot it at the same location. So we're going to call this one 49 degrees. That makes this item down here is the fire. Now, it also says how far to the nearest tenth of the mile is the fire from each station. So I need to find out both of these 2 sides. Well, let's label them. The side opposite Station A, I'm going to call little a. And side opposite Station B is little b. All right, if I know that this part right here is 28 degrees, then I know 90 minus 28 gives me 62 degrees inside. I'm just going to label what I know. And then same idea over here. The inside here is going to be 41 degrees because 41 plus 49 makes 90. So now I know those 2 angles. I can find my third angle because the inside of a triangle, angles add to be 180 degrees. So 180 minus my 62 minus my 41 should give me 77 degrees. So now I know and maybe you need to write it out, I should say. So 180 minus 41 minus 62 is going to equal 77. Okay, not a problem. I know one side length, I know all 3 angles, and I have that the 77 is paired with its side length of 15 miles. If I have a pair of items that are linked, a degree and its side opposite length, then I know no matter if I have a degree or the side length, I can use law of sines. So for me, this is a law of sines problem. And we're going to use law of sines. And again, your sine portion of that can be in the numerator, could be in the denominator. Doesn't matter as long as you keep them consistent on both sides of the proportion. So maybe we'll do, let's do sine. Sine 77 over 15 degrees is going to equal sine, and which one do you want to do? Do you want to do the A or the B? Well, I'm going to go with A first. So this would be sine of the degree 62 over A. Cross multiply, all of that good stuff. Well, maybe I'll show it. We have A sine 77 degrees. Now remember, A sine means they're being multiplied. Equals 15 times sine 62 degrees. So A is going to equal 15 sine 62 divided by sine 77. And all we have to do is plug it into our neat calculator, and you're going to have the approximate length of A is going to be 13.6 miles. Now let's put that in actual verbiage. We would say, well, let me put it right here, that station, well, A is actually from station B to the fire. So station B is 13.6 miles away from the fire. Now at this time, I need to find B. No worries, we can do it again. And I'm still going to use law of sines. For me, it goes quite fast, less calculation that's needed. So let's set it up. And maybe this time I'll set it up with the little b on top. And again, I want my pairing. So I'll do the side length on top this time. It doesn't matter as long as they stay consistent. So 15 over sine 77 degrees. Oh, that should not be a degree mark. That's out of habit. I wish I invented whiteout. And then that's going to equal the side length over the angle. So little b over sine of that angle b, which is 41 degrees. Then we have crisscross. So I have 15 sine 41 is going to equal b times sine 77. Now remember, this is being multiplied. I only want b, so I divide by sine 77. So I have b equals 15 sine 41 over sine 77 degrees. And it doesn't matter if you have the b on this side and switch sides, but what's in the numerator should still be in the numerator. So b is approximately, and I'm going backwards, 10.1 miles, and that's fine too. So we would say that this time station A is 10.1 miles away from the fire. Now, hopefully that helps. Getting those bearings correct is very important, but I believe you can do it.